Hello everyone. Welcome to the course Formal Language and Automata Theory. In this video, I'm going to explain tips for preparation of your end examinations, especially for JNTUH R18, third year, first semester, CSC and IT. Your end examinations will be going to be commenced from February 9th onwards. So our first exam as per the JNTUH calendar is the formal language and automata theory only. So many of them, they are confusing which topics we have to prepare. So all are the problems, how to face it. To overcome all these, so I will give the tips for your preparation of your end examinations. As for university pattern latest, the pandemic pattern, the question paper consisting of 8 questions, you have to answer any 5 questions. So earlier your pattern is unit-wise internal choice. At that time compulsory, you have to prepare all the units. Now there is no such situation. So overall, any three units if you can prepare pakka, compulsory you will get minimum 5 questions. Out of 8 questions, you have to answer any 5 only. That is the examination pattern. So now, which are the units you have to concentrate more? So on which unit more problems will be given? What type of questions will be given? So like all these doubts will be going to be cleared in this video. First here, I am going to present entire of the course Formal Language and Automata Theory. We are having around 18 plus problems, combination of all the units. So all these problems solutions are available in my official YouTube channel. So in YouTube, you can search Rasineni Madana Mohana. Directly you will get my channel link. You can subscribe it. Now in playlist, you can check Formal Language and Automata Theory, one separate title, which consisting of 65 plus videos. From the first unit to last unit, each and every topic as per the syllabus are covered. Even for every problematic topic, lively, many problems are solved. So you can make use of all this. Okay, now the first problem in unit 1, conversion of NFA with epsilon to NFA without epsilon. So in the examination, the question will be given, eliminate epsilon moves for the given NFA with epsilon, or for the given NFA, construct the NFA without epsilon moves. Like any type of question will be given. The question will be given in the form of transition diagram or transition table. Anything, no problem. That means the transitions with epsilon are there, means that is NFA with epsilon. Then you have to remove epsilon moves. For that, the procedure already there in our lectures. So you can go through this. This is the first problem in first unit, conversion of NFA with epsilon to NFA without epsilon. Then coming to second problem, you are having non-deterministic finite automata without epsilon moves. That means previous one is NFA with epsilon. Now you are having NFA with epsilon. From this, how to construct DFA? Now the question will be given like this: construct DFA for the given NFA. Then for the given NFA, find its equivalent deterministic finite automata. Like any question will be given. But the non-deterministic finite automata without epsilon only, you can apply this method. With epsilon means again we are having separate method for construction of DFA from the NFA with epsilon. So conversion of NFA to DFA, we are having method 1. In method 1, what we will do, in DFA, states q dash equal to 2 power q. So then from the given NFA, whatever the states, then 2 power mod q we can find out. Then for all the states, we will find the transitions. Then on all the inputs, then you can find out the equivalent DFA. That is method 1. Then, but the same conversion we are having method 2 also. Conversion of NFA to DFA method 2. In method 2, what we will do, here we no need to find all the states transitions from the 2 power q. What you have to do, you can take the initial state of NFA. For that, you can find out the transitions with all the given input symbols. Then on any input, if any new state occurred, again you can consider the new state is the next state of DFA. Again, for the new state on any one input, if you will get again a new state, again that will be considered the next state of DFA. Like that, you have to continue till no more new states are added. So in this method, the advantage, if the given NFA contains more states, here automatically some unreachable states are eliminated. Here we no need to find all the states transition. This is the advantage of this method. If NFA contains more states, you can use this method. Then our third problem, now conversion of NFA with epsilon to direct DFA. So previous two problems, first one is NFA with epsilon to NFA without epsilon. Second problem, NFA without epsilon to DFA with two methods. Now suppose we want NFA with epsilon to direct DFA. Generally, what we will do here, first two problems again we have to apply. First NFA with epsilon to NFA without epsilon. Then NFA without epsilon to DFA, but that is a lengthy process. So we have to manage the time in examination. For that, what we have to do, we are having one direct method, conversion of NFA with epsilon to direct DFA using set construction method or subset method. You can use this method. Even in regular expressions also, many cases, the question will be given construct DFA for the given regular expression. At that time also, this method we are going to use. Now this is the problem on NFA with epsilon to direct DFA. Use set construction method. This problem solution already available in my channel. You can make use of it. Then next problem. So we are having in first unit itself finite automata with output Moore and Mealy missions. So now the Moore mission, Mealy mission. Suppose Moore mission is given, how to convert into Mealy mission. Then Mealy mission is given, how to convert into Moore mission. Two problems are there. In these two, definitely we can expect one question. Then previous three problems we can expect one question. From unit 1, compulsory you will get two questions. So conversion of Moore mission to Mealy mission, one problem. Then the reverse, conversion of Mealy mission to Moore mission. So these are all the various problems related to first unit. You can prepare all these 5 problems pakka. Definitely you will get 2 problems from the first unit. Then theory questions. Suppose theory questions only worst case you will get. Suppose the theory questions also maybe on these problems only. Explain the procedure for conversion of NFA to DFA or NFA with epsilon to without epsilon or conversion of Moore to Mealy to Moore, or sometimes define NFA with epsilon, define DFA, then define finite automata with Moore and Mealy mission with example like that. But these questions rare case only will get. If short answers are there, there may be chance, but you don't have short answer. All are long answers only. So maximum, even last pandemic time, March 2021 question paper also, all problems are given. Combination of these type of questions only. Like that you can prepare. Then coming to second unit. In second unit, the first problem, construction of finite automata. It may be NFA or DFA from regular expression. From this, definitely you will get one question. The question will be given like this. For the given regular expression, so on. So for example, 0 plus 1 whole closure, 0, 1, 1. Or 0 plus 1 whole closure, 0, 0, 0 plus 1 whole closure. Or 0 plus 1 whole closure, 0, 0 plus 1, 1, 0 plus 1 whole closure. Like these are some standard regular expressions. From these type of regular expressions, what they will ask, construct NFA with epsilon, that is category 1. Then construct NFA without epsilon, category 2. Then construct DFA, that is category 3. See, in our examination, whatever the 3 types of automatons they will ask to construct, based on that only you can solve the problem. If the question is construct NFA with epsilon for the given regular expression, means directly as per our Clean's theorem part 1. So as whatever the rules we have mentioned, so directly you can construct NFA with epsilon by default by eliminating each operation from the regular expression. Like we are having union format, concatenation format, closure format. For these type of cases, you have to remove one by one, then you can draw their automata. Finally, combine all the individual regular expression automata, then you will get the final automata. So that is by default, you will get NFA with epsilon. Okay, if your question is NFA with epsilon, means up to this you can stop. If the question is NFA without epsilon, for example, specifically if they will mention construct NFA without epsilon for the given regular expression, means from this again we are having the first problem, first unit, conversion of NFA with epsilon to NFA without epsilon. So that method we can apply. If the question is DFA, now directly from the regular expression you can draw NFA with epsilon, direct 1 or 2 steps. Then now we have NFA with epsilon. Now NFA with epsilon to direct DFA in first unit, one problem we already mentioned, using set construction method. That method you can use. Like Like that, based on the given question, you can plan. So which method we have to use. You have to manage the time also. That is very important. Don't keep on spend on one problem. So you have to balance for all the 5 problems which are going to be attempted. So then next problem in second unit. Now you are having finite automata. From finite automata, how to construct its regular expression. Here we are using Ardens theorem. So Ardens theorem, what Ardens theorem says, if P and Q are 3 regular expressions, if the expression will be like this, R equal to P plus QR, or R equal to R plus QP, is like that. Then the Ardens theorem says R equal to QP closure. That means first for the given automaton, you can write set of equations from the automaton, then you can solve the equations. The final solution is whichever the final state in the given automaton, that final state equation solution is your resultant regular expression using Ardens theorem. Every time you have to apply Ardens theorem for the equations. Then by using simple substitution, like in our mathematics linear algebra equation solving, similar process we can use, but every time we can apply R equal to Q plus RP, then R equal to QP closure. That is a solution, or Ardens theorem solution. Okay, now suppose your automaton contains more than one final state, then what is the solution? Means union of all the final state solutions is the resultant regular expression. So definitely from regular expression to automata, automata to regular expression. Definitely you will get one question, sometimes 2 also you can expect. So then next one, we are having one concept, equivalence of finite automata or finite state missions. Suppose 2 automatons are given. When you can say these 2 are equivalent, we are having equivalence algorithm developed by E.F. Moore. So as per that, the behavioral equivalence can be established by constructing comparison table by taking the pair of states from initial state combination from both the automatons. From that on first input, second input, what are the next states? Again, their combinations we can take like that. In the any comparison table of column 2 and 3, any pair which is combination of either final or non-final, then we can stop. We can say the 2 automatons are not equivalent. Suppose any case in column 2, column 3 of comparison table, you are not getting any pairs with the final state, non-final state combination. So then all are the other pairs. Then further no new pairs also repeated. At that time we can say the 2 FSMs are equivalent. Like that you can use this equivalence. Then this is a very simple one. So next very important problem in second unit, minimization of finite automata. Here finite automata means actually they will use deterministic finite automata. The automaton does not contain epsilon moves. Even the automaton does not contain more than one next state from the same input symbol. They will use direct DFA. Then we have to minimize the given DFA. Here what we discussed the method table filling algorithm. Using table filling algorithm, we can take the pairs of states combinations by excluding diagonal combination, and then we can establish the equivalence. First, we have to mark all the entries, which are the combination of final, non-final, or non-final, final. You can mark in with into mark. So finally, whatever the pairs which are not marked, then you can say those are equivalent classes. Then both equivalent classes will be merged into single state. Then you can construct the final DFA after merging the equivalent states. That is the minimized DFA. So from second unit, regular expression to finite automata, minimization of DFA. Definitely you'll get these 2 questions. If regular expression to finite automata not means Ardens theorem, that is automata to regular expression. Compulsory out of these 3, you will get 2 questions. The equivalence of finite automata maybe rarely you can expect. So these are all second unit problems. Then coming to third unit. Third unit, first part we are having context-free grammar introduction. In context-free grammar, definitely you will get one part A question, like maybe 5 marks or 7 marks. So what they will ask, for the given context-free grammar, find the leftmost derivation or rightmost derivation for so-and-so string. Also draw the derivation tree or parse tree, and also check whether the grammar is ambiguous or not. Like this combination question also we can expect. In all question papers compulsory, this is also there. It's a very simple one. Then the next question, the second part of third unit, design of pushdown automata. Compulsory here you can expect one question. Generally, in the design of PDA, we don't have standard procedure. First, what we have to do for the given language, first we can identify the strings satisfying the given language. From the strings, now we can, in the design of PDA, the basic guidelines are first we have to push some occurrences of the inputs onto the stack. Then you have to pop the symbols from the stack. Then you have to accept. The three cases, any design of PDA, the three steps: first acceptance, first insertion, that is push; second one pop, that is deletion; third one acceptance. Acceptance step is common for all problems. So generally the standard problems what we discussed in design of PDA, the first one, design PDA for the language L equal to A power n B power n such that n greater than 0 or greater than or equal to 1. Then L equal to W power R such that W belongs to 0, 1 whole closure or A, B whole closure, any of this problem. See, any problem given like this, W power R, that is nothing but palindrome. W with the string, W power R, reverse of the string. Sometimes W power R, they will give the separator, middle of the string, it may be some dollar symbol or small c, or sometimes any special symbol will be given. So if any such symbols are given, now middle of the string, whenever entered, then you can skip the state without changing the stack symbol. If middle of the string is not given, then what you have to do, W power R, in between you can take epsilon. Like that you can design the palindrome problem preferably, so you can expect. Then another important problem, balance parentheses. If it is open brace with square bracket, with the set bracket, then with function bracket, then similar closure bracket. So this is another problem. Preferably these three problems you can prepare. So like that, any general question also with that procedure you can able to construct the PDA. That is the design of PDA. This is also one definite question. Next, two more problems in third unit. There is a conversion of context-free grammar to pushdown automata, then pushdown automata to context-free grammar. See here, the problem is the questions are given A-B combination. That's why sometimes all problems also we can expect A is one problem, B is another problem. That is one question from third unit. Then another question from third unit, another problem A, another problem B, plus AB 2. Total 4 problems. So we expected. So maybe given also. So last time also like this, the question paper will be set. That's why you can prepare all the problems. Then you can easily attempt any question. Now the next problem is conversion of context-free grammar to pushdown automata. We have context-free grammar. From this, how to construct PDA. This is very easy. Then the reverse conversion is also there. Conversion of pushdown automata to context-free grammar. This is somewhat lengthy, but the standard rules are there. As per the rules, we have to construct. So now in third unit, you can see context-free grammar, derivation tree, ambiguity one problem, then design of PDA, then CFG to PDA, PDA to CFG. Total 4 problems are there. So then before that, we are having this one also, that is pumping lemma, the theory question. So this is very important. In second unit also we are having pumping lemma. They will ask question, theory question means like on this, state the pumping lemma and explain application of pumping lemma. Or sometimes they will give problem like this, show that the language L equal to A power n B power n is not regular. Then show that the language L equal to A power n B power n C power n is not context free. Here don't confuse. In regular language pumping lemma, the question will be given so that the language so and so is not regular. Not regular means you can use pumping lemma for regular language. Whereas the question is so that the language is not context free means you can use the context free pumping lemma. For both lemmas, what is the difference? In regular language pumping lemma, the string is divided into 3 substrings, that is X, Y, Z. Then whereas context free language pumping lemma, the string is divided into 5 substrings, U, V, X, Y, Z. That is the only difference. The application, everything, the process is same as in regular language pumping lemma, context free language pumping lemma. And sometimes closure properties of regular sets or regular languages, then closure properties of context free languages. So these questions may be expect theory questions. These are very simple, just theorem statements. Okay, now in fourth unit, we are having 4 problems. The first one is context free grammar, eliminating useless symbols, null productions, and unit productions. So directly, sometimes they will give one context free grammar with any of these combinations. They will ask to eliminate either useless symbols or null productions or unit productions, or combination also they may ask. That's why definitely you can prepare this question. Once you can prepare this question, the next topic that depends on this one only. Again, the same process, whatever we discussed here, that will be repeated in the next problem. That is, the next problem is called as Chomsky normal form. So reducing the context-free grammar into Chomsky normal form, this is very important. So to convert any context-free grammar into Chomsky normal form, the basic conditions are the grammar does not contain null productions, the grammar does not contain unit productions, then the grammar does not contain useless symbols and useless productions. In the previous problem, whatever we eliminated, all should be eliminated here. Then from that only you can convert the grammar into Chomsky normal form. The next normal form, Greibach normal form. So to convert a given context-free grammar into Greibach normal form, the previous two problems are required. Why? Because first the context-free grammar is in Chomsky normal form. Then only from CNF we can construct its GNF. Directly we can't construct the JNF, which is the grammar is not in CNF. Suppose if you want to convert the grammar into CNF, again we have to remove the epsilon productions, unit productions, useless symbols are useless productions. So once you know the first two problems, then the GNF is very easy. So from CNF, GNF, then elimination of the three categories, definitely you will get 2 questions. Then next one, in the fourth unit, last part, design of Turing machine. So before this, actually, we are having that pumping lemma also. That was not in third unit, actually. Here, this was there. So pumping lemma statement you can prepare. Then some example problems you can prepare. Then closure properties of context languages. Those are very simple questions you can prepare if you may get part A, part B like. Then last problem in fourth unit, that is Turing mission. Here, Turing mission maybe theoretically means define Turing mission and what are the applications, what is the instantaneous description, etc. But rare case you can expect, but most of the cases you will expect the question design of Turing machine. They will give one language, for the language how to construct the Turing machine. So many examples we demonstrated. So in our channel, all the videos are available, you can use. So these are all the fourth unit questions. Then coming to fifth unit actually we are having types of Turing machine. That is theory question. You can expect that question because that is directly in the syllabus. Types of Turing machine. Then halting problem, then undecidable problem about recursive and recursive enumerable languages. All theory questions you can prepare. Why? Because there is chance of giving theory questions only from fifth unit. Fifth unit you don't have problem. If problem means, so actually this is one problem, construction of Turing machine for computable functions. This is not in our syllabus. Actually, in worst case, if any problem on this given, this was very simple for any function how to construct Turing machine. This we discussed. Okay, then next problem in fifth unit, no problem. The theory question, a very important, PCP, post correspondence problem. Then modified PCP, modified post correspondence problem. So PCP, they will ask define PCP problem and check whether the following lists have PCP solution or not. We can expect that is small problem only. So in fifth unit, so you can prepare types of Turing machine, then a PCP problem, then some undecidable theory questions. So definitely we will get one question out of these theory questions. Okay, these are all the majorly 18 plus problems, whatever till now we discussed. So out of 18, see compulsory the problems on these topics only. So if you can prepare first unit, third unit, second unit, third unit, pakka, you will get 5 to 6 questions. First 3 units, if you can prepare 5 to 6 questions, definitely you can expect out of 8. Then fourth unit also, if you can prepare, definitely 1.5 question will be given. Then fifth unit, you can expect only 1 question. Majority of the cases, previously we have seen only 1 question. So pakka 1, 2, 3 you can prepare. Then suppose fourth unit you may feel difficulty, at least fifth unit you can prepare. Then easily you can write 6 to 7 questions like that. Like that you can plan. So my advice, prepare all these 18 problems. So then any given problem, so you can easily attempt. So if you are getting confused in design of Turing machine or design of PDA, you can skip this to prepare all problems. So definitely you can answer easily. You can get good score. Like that you can plan. Okay, all of you make use of this video and all the lectures available in my channel. So all the best for your examinations. So see you in future for new courses.